A join hides a DJ. Another join inflates the crowd. A CTE looks like alphabet soup, and a ranking query crowns the wrong winner. In the next few minutes, every bug becomes one beat in a final query. Can you find the top DJ on each stage? Here is tonight's mission. Return one winner for the main stage and one winner for the neon stage. To unlock that result, we need 4 skills in order: match the tables, protect the grain, organize the logic, then rank inside each stage. Our tiny database has 3 tables. DJs contains 1 row per DJ. Sets contains 1 row per performance. Votes contains 1 row per audience score. Those different row meanings are called grain, and forgetting them is where our trouble starts. Think of an inner join as a strict club bouncer. Your name must exist on both lists, or you stay outside. A left join is different. Everyone from the left guest list stays, even when the right table has no matching wristband. Compare the lists. 4 DJs are registered, but only 3 have a scheduled set. Luna Loop has no matching DJ ID in sets. Now predict the inner join result. Will SQL keep Luna, return nulls, or remove her row completely? The inner join removes Luna because no set matches her DJ ID. Notice another surprise. We still get 4 rows because DataWave plays twice. 4 result rows do not mean 4 unique DJs. The join question and the row grain are separate decisions. Switch to left join, and Luna returns. SQL preserves every row from DJs, then fills unmatched set columns with null. Use this when your question begins with all DJs, all customers, or all products, even those with no related activity. Inner join keeps matched relationships. Left join preserves the complete population on the left. Choose the join based on the business question, not habit. And after every join, inspect the row count and ask yourself, what does one result row represent? Now, the club scanner gets excited. Set 102 has 3 audience votes, so joining sets to votes repeats that set 3 times. But one performance, scanned 3 times, is not 3 performances. SQL is not drunk. The grain simply changed. Follow set 102 through the join. It matches vote 3, vote 4, and vote 5, producing 3 joined rows. That is correct relational behavior. The mistake happens only when we count those joined rows, as if each row still represented one set. This query uses count star after joining all the votes. The answer is 8, not 4, because the result now has 1 row per vote for a set. Count is doing exactly what we requested, but our metric question was poorly defined. Count distinct set ID, and the answer becomes 4. 4 performances received votes. For larger pipelines, another safe pattern is to aggregate the votes first and then join. The important idea isn't distinct itself, it's matching the metric to its intended grain. DJs means 1 row per DJ, sets means 1 row per performance, and votes means 1 row per vote. After the join, one row represents for 1 performance. Write that sentence before calculating any metric, and duplicate bugs become much easier to spot. A good DJ set has named stages: intro, build, and drop. A readable SQL query can do the same. We'll call the joined rows base events, the averages vote scores, and the final output ranked. Each name clearly explains the next transformation. A deeply nested query forces your brain to hold every step at once. CTEs turn that maze into a pipeline of named results. This doesn't guarantee faster execution, but it gives us clearer places to read, test, and debug. First, base events joins DJs, sets, and votes. We select only stage, DJ name, and score. The output grain is clear, 1 row per vote for 1 set. This small contract makes the next aggregation much safer. Next, vote scores groups base events by stage and DJ name, then calculates the average score. 8 event rows collapse into 4 DJ stage rows. Ranking before this step would rank individual votes, and that isn't our business question. While building, temporarily select from vote scores and inspect the 4 averages. On the main stage, DataWave has a score of 5 and Neon Fox has 4.5. On the Neon stage, Byte has 4 and DataWave has 3. This checkpoint confirms that our grain is ready for ranking. CTEs name each transformation stage, reduce mental load, and create useful checkpoints for debugging. They aren't automatically faster than subqueries. Use names that describe the data being produced, like base events and vote scores. instead of vague names like temp1. A window function is like a scoreboard, one that resets for each group without collapsing the rows. Partition by stage creates separate scoreboards, one for main and one for neon. Then, order by average score places the strongest performance first within each stage. Read the window from the inside. Partition by stage tells SQL where the ranking restarts. Order by average score descending defines what best means. Dense rank assigns the positions, keeping tied scores together without leaving gaps. And the over clause defines the neighborhood, with scores of 9.8, 9.8, and 9.2. Row number assigns positions 1, 2, and 3. Rank gives us 1, 1, and 3. Dense rank gives us 1, 1, and 2. For shared podium positions without gaps, choose dense rank. Apply dense rank to vote scores. The ranking restarts whenever the stage changes, so data wave becomes number 1 on the main stage, and byte beat becomes number 1 on the neon stage. Every DJ row remains visible, because window functions add information to the rows instead of grouping them away. Now, let's combine the first 3 lessons. Base events joins the source tables at the vote grain. Vote scores then aggregates the data to 1 row per DJ per stage. The order matters. First, establish the correct grain, then ask the window function to compare the performers. The ranked CTE assigns dense rank within each stage. Then, the final where clause keeps only rank 1. Mission complete. Data wave wins the main stage with 5.0, and byte beat wins the neon stage with 4.0. The answer is now explainable, testable, and correct. SQL isn't about memorizing commands. It's about seeing the shape of the data, what matches, what multiplies, which transformations deserve names, and where a calculation should reset. You cleared all 4 levels. Now, save the query, replay the beat, and keep building.